this question here that reads, find the differential coefficient of the following using logarithmic differentiation here. So first that we're going to do here is we're going to try to simplify the function that we have here so that we have it in powers of numbers instead of the roots that we have here. So this here is the same as y is equals to, open brackets, 1 plus cos squared x, the power 1 over 2 divided by 1 plus sine squared x to the power 1 over 2 here. So now, remember we have a property of logs that states that if you have log a divided by b here, then this here is the same as log a minus log b there. So then here, so we're going to introduce logs on both sides of the expression that we have here. So in here we just say introducing logs on both sides. So introducing so now if we introduce logs on both sides, so this side we're going to have ln y is equal to ln open brackets, we have 1 plus cos squared x here, the power 1 over 2 divided by 1 plus sine squared x, the power 1 over 2 like this here. So according to this property of logs that we have there, we're going to simplify this further. So here, basically we're going to have ln y is equal to ln open brackets 1 plus cos squared x here, the power half, minus ln open brackets 1 plus sine squared x here, the power half like this here. Then there's another property of logs such that if you have log of a to the power n, this is the same as n log a like this here. So we're going to utilize this property again on these terms that we have here. So it's simply just going to drop the powers. Then here we have ln y is simply equal to 1 over 2 ln open brackets 1 plus cos squared x here, we close, minus 1 over 2 ln open brackets 1 plus sine squared x like this here. Okay, so now after we've simplified and used all the properties of logs there, we just go direct and differentiate this now. So here we say differentiating throughout. So differentiating throughout here with respect to x. So now here we're going to differentiate this expression that we have here with respect to x here. So then we differentiate with respect to x. On the right hand side we have ln y, we close here, equal to, we differentiate everything that we have on the right hand side as well with respect to x there. So ln open brackets 1 plus cos squared x here, minus 1 over 2 ln open brackets 1 plus sine squared x like this here. We close like that. Okay, so now let's start differentiating the terms that we have there. So if we differentiate ln y with respect to x here, so this is we're going to apply implicit differentiation here because we're differentiating y with respect to a different variable which is x here. So meaning that when we differentiate it, we also include the dy dx at the end there. So meaning that when you differentiate ln y, we're going to get 1 over y. Then since y and x are two different variables, so this will be dy like this here, equal to, then this side here, differentiating this term here, we're simply going to start first by differentiating the whole the way it is here. So we have 1 over 2 there. So when you differentiate this, we're going to have 1 over 1 plus cos squared of x. So here we apply the chain rule for this one. So then when you differentiate now the function that is inside here, so here we're simply going to have 2 cos x, open brackets, negative sign x, like this here. Then minus, we do the same thing this side, 1 over 2 there. So when you differentiate that term there, we're simply going to have 1 plus sine squared x. Then here on top there, we're simply going to have 2 sine x multiplied by cos x, like this here. Okay. So then here we continue. We have 1 over y dy dx equal to negative. So I have our half there, open brackets. Let's just factor out the half. So we have our half there, open brackets. We have negative 2 cos x sine x divided by 1 plus sine x, or 1 plus cos x rather. Let me just erase that. Okay, so here we have 1 plus cos squared x minus 2 cos x sine x, like this, divided by 1 plus sine squared x, like that. So we scroll down a bit. Okay, so now we know to say that this here that we have this term and that term there that we have identities there. So if those are identities, we can just say since sine 2x is simply equal to 2 sine x cos x here, we make a substitution where there's this here, we're going to put 2 sine x there. So meaning that here we have 1 over y dy dx being equal to 1 over 2 open brackets negative sine 2x divided by 1 plus cos squared x minus sine 2x divided by 1 plus sine squared x, like this here. So we close there. So now here we just try to, so then there we make dy dx the subject by simply multiplying throughout by y. So if you multiply throughout by y, we're simply going to have